Okay, today we are switching from multiplication properties with exponents to division. So dividing with the same base. Okay, again, we are going to be keeping the base that they have in common, and you subtract the exponent. So 6 minus 14. That would give us a to the negative 8. Okay, remember anything with a negative exponent's in the wrong position, so I need to move it, lose it. So my final answer here would be 1 over a to the 8. So in multiplication, if we remember with the same base, we added the exponents. On power to power, we multiplied the exponents. On division, again, you keep the base that they have in common, but you're going to subtract the exponents. So if I look at my next one, these both have a base of c. Negative 1 minus 5 gives me c to the negative 6. And d, 3 minus a negative 4 gives me d to the 7th. I'm not done because the c has a negative exponent, so I need to move it, lose it. The d already has a positive exponent, so it stays in the numerator. C gets moved, I move it, lose it. So my final answer is d to the 7th over c to the 6th. The real world problem solving here. In 2000, the total amount of paper and paperboard recycled in the U.S. was 37 million tons. The population of the U.S. in 2000 was 281.4 million. On average, how much paper and paperboard did each person recycle? Okay, well, a couple things you have to point out. They're talking about in millions. So 1 million is equal to this. So when I write these numbers, the amount recycled was 37 million, so that's 37 times 10 to the 1, 2, 3, 4, 5, 6 over 281.4 million. So we write it times 10 to the 6. That's how you would write million in terms of scientific notation. It's not actually scientific notation because if you look at the A's, those are both greater than 10, so we would have to change them if we wanted it to be in scientific notation. So if I look here, if I want to change this to be in scientific notation, I'd move my decimal, let me get a different color so it's easier to see, one place to the left, so it'd be 3.7 times 10 to the 7th over 2.814 times 10 to the 8th. And now I'm going to go ahead and multiply this. It's going to give me an approximate number. 3.7 divided by 2.814 is approximately 1.3 times 10 to the, and I subtract my exponent, so it's going to be 7 minus 8, which is negative 1. This is written in scientific notation because this is between 1 and 10. I have a base of 10, so I can go ahead and write my final answer. Each person recycled 1.3 times 10 to the negative first tons of paper and paperboard in 2000. Okay, example 3 now. We're doing power to power with quotients involved. So we have to remember our power to power rule from last week, or last section. Power to power, remember we multiply exponents. So this would be, and we have to do both the numerator, everything in the numerator and everything in the denominator. So it'd be 4 to the 3rd over x to the 6th, because power to power means you multiply exponents. 4 to the 3rd is equal to 64. X to the 6th does not simplify. I can't go any further because they have no bases the same, so my answer is 64 over x to the 6th. Our next one is the quantity x over y squared to the 4th. So I get x to the 4th over y to the 8th, because remember, power to power, you multiply exponents. The bases are not the same, so that is my final answer. Now we are going to simplify exponential expressions, so these just have more parts, and if you notice, there's also a lot more negatives. So if I look at this first one, this negative is telling me everything inside this parentheses is in the wrong spot. So I need to flip or use the reciprocal and get 5/3. Since I flipped everything, I moved everything, and I lose the negative sign. Now I can do power to power, so I get 5 squared over 3 squared. 5 squared is 25, over 3 squared is 9. 25 to the 9th then gives me a final answer of 2 and 7/9. Oops, sorry. Yes, 2 and 7/9. Our next one over here is a little bit more complicated. First of all, everything on the inside needs to move because of that negative exponent. So I'm going to flip y over 2x, and I always put my negative sign with the numerator. So I'm going to keep that negative sign with the y. It'll just make it easier for me later on. I'm going to say everything now is to the 4th power because I moved everything on the inside because of the negative exponent, and then I lost the negative sign. So now I have negative y to the 4th power over 2 to the 4th x to the 4th. Negative y times negative y times negative y times negative y. 4 negatives times one another give you a positive. So I'm going to have a positive y to the 4th, and if you're not sure why, it's because of this. If you have a negative times a negative times a negative times a negative, these two go together to make a positive. These two go together to make a positive. Positive times a positive is a positive. In the denominator, 2 to the 4th is 16. X to the 4th doesn't simplify. Here's my final answer. I can't go any further because these do not have the same base. Okay, let's just review our exponent rules very quickly. When you multiply with the same base, you keep base. And you add the exponents. That was our first rule. Our second rule was then power to power. Again, you keep the base, but this time you multiply the exponent. And then finally our division one is, again, you keep the base because that's what they have in common, but you are going to subtract the exponents. Do not forget, you are not completely done with the problem if there is a negative exponent, because that just means you need to move it and lose it. Go ahead and complete your quick checks and then check with your schedule on the assignment.